Recall that in case 1, when the denominators are the same, adding fractions is pretty easy. Denominators are the same means that both numbers reside on the same number line, and therefore you add the steps, just like in the normal addition of integers, the steps being the numerators. Case 2 is a little more involved in that the denominators are not the same, but one denominator divides the other. That is, one number line is part of the other number line. So what you have to do is you have to move the fraction with the smaller denominator onto the number line of which it is a part, and that is building up one of the fractions, so they will both have the same denominator. The case we're looking at right now is the case of the two numbers that have different denominators, and none of them is part of the other one, so you must do something to both of them. And the idea is that of the LCD, least common denominator, and what you do is you go to a third number line which contains enough divisions to have both of the number lines on it. That third number line with the least number of divisions, that's the least common denominator. And to find it graphically, it's pretty easy. What you do is you draw the number line for divide by 4, draw the number line for divide by 6, and just on a new number line, put all the division points that you need. So for example, this division point here is not on this number line. So you'll put it on the new number line. And you do this for all the division points, and you make sure all the divisions are equally spaced. And then you count how many division points you have to make, and the answer is 12. It's not 6 times 4, it's not 24, it's 12. Of course, 24 is inside 12 is contained inside 24, because if you take 12 division points and divide by 2 each one of the pieces, then you'll get the 24 pieces. Simple as that. Now, using the number lines to add fractions when the denominators are not the same is just a pictorial way of understanding what's going on. Still, you want to do it algebraically, but now you'll have an understanding of what the algebra stands for. Okay, so the key is to find the LCD. Other than the one graphical fashion that I just explained, there are 3 other ways to find the LCD. One is using an Excel type idea by starting with the smaller number and starting multiplying by 2, 3, 4, and 5, and so on. So make a list of multiplication of your numbers by the various numbers 2, 3, 4, 5, and so on. And the first time the two lists agree, that is the LCD. Another way would be to factor both of the numbers and see what the GCF is, the greatest common factor, which is usually easier to see what they share. And then you multiply the two numbers and divide by the GCF. That is, the numbers that they share, when you write things down, you only write once. When you multiply the numbers they share, it is represented twice, once from each number. So by dividing it out, that means you're just doing it one time. And the third way is the way that probably the easiest for calculation is to factor the numbers as much as you can, then write all the factors and choose the highest power on each factor that appears in each number. So here we'll choose the factor power 2 because there's a 2 here and a 1 here. The bigger one is the 2. And on 3 we use 1, and so the answer is 12. And that's the way we find the LCD, and that's the way we add fractions in general.